All right, so we're moving on to 6.3. We're going to head towards more exponential work. Okay, so our first problem is going to ask us to determine linear, exponential, or neither. So we did a linear one a couple chapters ago, I think, when we had our t-shirt. So -1, 0, 1, 2, 3, 3, 6, 12, 18, 30. So there's my t-chart. So to do linear, you want to do average rate change, which is also slope. Okay, they all need to be the same. So we're going to do slope. Okay, so we're going to do 6 minus 3 over 0 minus -1. That gives me 3. 3 over 1, which is 3. That one's perfect. Now we're going to do 12 minus 6. 12 minus 6 over 1 minus 0. That gives me 6 over 1, which is 6. So I already know that I have a problem. These do not match. So these would have to be absolutely the same. Must be the same for it to be linear. So it's not linear. Let's cross off linear. Not linear. Okay, for exponential, you want the ratio of consecutive outputs. You're like, what does that mean? Okay, that means we're going to take the outputs and divide them. So we're going to do 6 divided by 3 gives me 2. 12 divided by 6 gives me 2. Perfect so far. Then we're going to do 18 divided by 12. Well, that gives me 3/2. So right there, this is the problem. Okay, these two are the same. This one's not. So again, has to be the same, but it's not. So it's not exponential. So in this case, it's neither. Okay, so now you see how to do each one. So average rate of change would be linear. You have to get the same slope. Ratio of consecutive outputs. So you're going to do each one over the last one, each one over the last one, each one over the last one. They all have to be the same for it to be exponential. Okay, so again, it's neither. All right, so the other problems are all going to be very similar. Okay, so it's just a matter of catching on. Ugh. All right, so 65. 2 to the negative x equals 16. Okay, so we're going to make these all, we're going to look for base 2, 3, 4, 5, maybe 7, maybe 9, but mainly 2, 3, 4, and 5. Okay, so the left side's already at 2. It's already at 2. So now I want the right side to be 2. So I can make this, the left side stays the same, but 16, we need to think, well, 16 is what? So you can go, well, 2 squared. 2 squared is 4, so it's not that. 2 cubed is 8. 2 to the 4th is 16. So I can replace 16 with 2 to the 4th. When they have the same base, you can cancel them out. So I get negative x equals 4. So x equals negative 4. And if you were to check this, I'm going to do it in green. Hopefully you guys can all see this. So on the check, 2 minus a negative 4 equals 16. 2 to the 4th equals 16. Super easy to check. Check. Perfect. All right. So now it's going to get one step harder. All right. So 1/5 to the x equals 1 over 25. Okay. So if you're really good at this and you've taken logarithms and exponentials before, great. So you might be able to solve this a little bit differently. But if you haven't, or you're not really strong at it, again, I'm going to recommend base 5. Okay. So here on the left side, in order to make it base 5, we need to flip this 5 back up top. Well, the only way to do that is to make it negative. So I already have the left one fixed. All right. The right one is not, it doesn't have a 5 in it yet, but I can make it because 5 squared equals 25. So I can change this into 1 over 5 squared. Okay. And then it can take it back up top. So 5 to the negative x equals 5 to the negative 2. Negative x equals negative 2, and x equals 2. And again, I'm going to show you how to check this just because it's really easy. 1/5 squared equals 1 over 25. So if you want a 1/5 squared, let's do the super long-winded. 1/5 times 1/5 equals 1 over 25. Very obvious that it's 1 over 25. Check. Perfect. All right. Okay. 3 to the x cubed equals 9 to the x. Okay. Sometimes students want to make the 3 bigger. We're always going to take it down. So we want to take it down. So we're looking for base 3 here. So the left is perfect. 3 to the x cubed equals, well, 9. 3 squared equals 9. Okay, so I get 3 to the 2x. So it's multiplied together. Okay, it's not 2 to the x, it's 2 times x. Now I can drop them, and I get x cubed equals 2x. Well, that's not super nice, but I can work it because I can solve for x by setting it equal to 0, taking an x out, setting each piece equal to 0. So we're using all these algebra rules that we already know about. X squared equals 2. And don't forget that I have a cubed or a cubed here, however you want to look at it. So I should have 3 roots for the most part. So remember that I get x equals plus minus the square root of 2. So don't lose a root. Okay? So that's all that I want to do. A lot of this is hands-on. I really want you guys to work in groups to figure these out, okay? So it's kind of like in this section, either you get it or you don't get it. The other problems on the classwork are going to be ones that you're working on practicing using your calculator efficiently. So make sure to bring your calculator to class, either a scientific or graphing calculator. You need one that has exponents on it so that you can use it easily. Use the one that you're going to use for your tasks, okay, if possible.